Today we're going to look at how we can go from our egg geometry, from a plain egg geometry, whether it be a surface model or mesh, and go through a series of steps using the Grasshopper plugin for Rhino to produce the egg on the left. So it's made up of a series of Boolean Voronoi cells that I grouped into 3 sections, which conveniently were 3D printed and reassembled. So the first step is to start, in this case not with a mesh, but with a surface geometry. So I'll go ahead and hide that. So we have this. I've already launched Grasshopper. The file, unless the file name has changed by the time you guys are working on this, is called egg study. And when you open it, there could be more than one Grasshopper definition. We're going to focus on the first one, Voronoi. So step 1 is to associate the Rhino geometry with a boundary representation. So I will start by right-clicking, and then we want to set one boundary representation. Go ahead and select that, and we now have it. And basically the steps I followed were to first generate a random assortment of points within a space, or more specifically on a surface. And in this case, we want to generate the random points on the surface of the egg. So I ended up using the populate geometry component. So that is found under the mesh menu, triangulation, let's see, vector, grid, populate geometry. So, and it looks like this. So I already have that in play, and there are 4 inputs: geometry, which this can be a mesh, surfaces, boundary rep, or just curves even. You need to give it a number, so the number of points that you want to be populated. The seed, so this is just a randomizer. And finally, the points as a list. If you already know where they are, you can plug this in or know what they are. So we have our boundary rep, our geometry. That is going to get plugged into the geometry. And then if we just want to look at that, we can go ahead and preview the points. So what I did was I went to parameters and I created a point parameter, which just allows us to kind of look at what we have. So you can see, and if I go to a ghost or even a wireframe, you can see all of the points exist along the surface. So that's the first step. Now, once we have those series of points, we want to generate a 3-dimensional Voronoi, or collection of Voronoi cells. So this component is found under the mesh menu, triangulation, Voronoi 3D. Okay. Now this has 2 inputs. It has both a points input, which is drawn directly from our point generation tool. The other is a box, a bounding box. So what's convenient is that we already have the geometry. So we could plug that geometry directly in to the Voronoi tool. Unfortunately, if I go ahead and preview that, unfortunately it moves right to the edge of our egg geometry, and it clips the last fraction. So instead of doing that, which would have been more straightforward, I'm going to disconnect. And what I did instead was run it, I scaled it. So this was made a little more involved because we had to first find the centroid, or the center point of the volume. So the first step is from your boundary rep, you want to pull a volume command. So instead of going through the drop-downs, another way to search for any tool, any component within Grasshopper is just to double-click, and then you can search. So if you go into the search menu, key in volume, and there you have it. So this looks for just one thing, geometry, which we have, and it outputs two bits of information. One is the volume has a value, a numerical value, and the other, more importantly, is a single point, which is the centroid of that volume. So with that centroid, that center point, we can plug it into our scale tool, and we already have our geometry. And finally, it looks for a scale factor. So I could have just come in here and within F, I could have gone down to set a number, but I like to add sliders so there's some adjustability to it. So I have it just over 1 because I didn't need much. But you can see if I scaled this up and made the connection back, this should, you can see it's going to scale up our box. So I'm going to drop this back down. Let me go ahead and key in, just 1.1. There we go. Well, okay. So what we have now is a series of points and a bounding box. With those 2 bits of information, we have this series of Voronoi cells generated. And what's interesting is that it's all working back towards that central vertical axis of the egg volume. So now we're ready to bake this. So I'm going to go ahead and right-click, bake, and I'll go ahead and group this. Now, once we have that, I'm actually going to select everything because the egg geometry is part of this as well, because there's a few additional steps that we're going to need to undertake outside of Grasshopper. So I'll take both of these and I'll copy them over, and I'll delete what I'd created there, and the egg geometry can stay in place. So what we should have here are 2 things: the series of Voronoi cells and a egg geometry. So let's go in and want to do a few things. I'm going to minimize our Grasshopper file now, and I'll actually pull this out. And the first thing I want to do is select this and turn off the ISO curves so I get a better idea of what I'm working with. And if we look in the ghosted view, you can sort of get a hint of the egg within this. So there are a few steps here. The first thing I want to do is find the intersection of all of these cells and my egg. So we'll simply do a Boolean intersection. So set the first set of surfaces, okay, and the second set, okay. And there we go. So this gives us our overall volume. So this gives it, if we turn on shaded, this is a clearer view of what's happening. And so this is actually just fine. And what you'll notice when you ungroup is that each one of these is separate. And it's actually kind of interesting in that why don't we pull this out? You can see that they're all moving essentially back towards that central core, which produces kind of interesting space, interesting cavity. You could leave it at this. You could sort of break this down. You could actually go in and carve each of these pieces back individually to kind of create a terrain within the egg. What I had done was actually offset my shell into the shell, into this volume about 1/4 of an inch, and then did a second difference operation to create a shell. And that's actually how I ended up with, let's see, I don't know if I have it here. That's how I ended up with this. Right, because each of these panels is only 1/4 inch thick. So this is one approach within Grasshopper to quickly start to, again, break down the surface of the egg geometry and come up with both a strategy for kind of a series of shells that key together, that reassemble, and also potentially have a logic that breaks down even further to a series of these Voronoi cells or panels. Okay, thanks guys.